Hello everyone, I am Dr. Jacobi, Assistant Professor, Department of Mathematics, Bardhaman College of Engineering. Today in this video, I am going to explain the Jacobi iteration method for solving linear system of equations. Let us now see what is system of linear equations. System of linear equation involves two or more equations that has same set of variables. Here we are considering three linear equations which involves x, y and z as variables. Consider the system a11x plus a12y plus a13z is equal to b1, a21x plus a22y plus a23z is equal to b2, a31x plus a32y plus a33z is equal to b3. It has three linear equations and the variables are x, y and z. The solution to this linear system is the set of variables x, y and z that satisfy these equations simultaneously. As our main focus is Jacobi iteration method, to solve this linear system of equation using Jacobi iteration method, the system must satisfy the diagonally dominance property. Let us now see what is diagonally dominance property. Suppose this given system satisfy the diagonal dominance property, that is the modulus of coefficient of x is greater than modulus of coefficient of y plus modulus of coefficient of z. This is the first one. Second one, the modulus of coefficient of y must be greater than modulus of coefficient of x and modulus of coefficient of z in any of the equation. Here we are considering from equation 2. And last one, the modulus of coefficient of z should be greater than modulus of coefficient of x and modulus of coefficient of y. This is the diagonal dominance property. If the system satisfies this, then we can solve the system using Jacobi iteration method. Now let us understand the working procedure of Jacobi iteration method. Jacobi iteration method is an iterative method and it is used to solve simultaneous system of equation. It is performed in iterations and we get approximate values which gets improved after every iterations. Let us now see how we proceed in this method. First of all, we will solve the given equation for x, y and z, which is x is given as 1 by a11 b1 minus a12y minus a13z. Similarly, we get y and z. We give equation number 4, equation number 5 and equation number 6. Also, we will take initial approximation as x0, y0 and z0 is equal to 0. Now the first approximation is given by, we will put x equal to x0, y equal to y0, z equal to z0 which are 0 in equation 4, 5 and 6. And we will get the first approximate values as x1, y1 and z1. Now the second approximation, in the similar way, we will use x equal to x1, y equal to y1, z equal to z1 in the equation 4, 5 and 6. Then we will get the second approximate values as x2, y2 and z2. The third approximation and fourth approximation, we will get the similar way. And we will continue this process until we get same approximate values for x, y and z. Now let us solve one system of equation using Jacobi iteration method. Let us now solve this system of linear equation by Jacobi method. First of all, we will take this as equation number 1, this is equation number 2 and this is equation number 3. To solve this by Jacobi method, we need to first verify whether it satisfies the diagonally dominance property or not. Diagonally dominance property. So for the first equation, the coefficient of x is 4, mod of 4 is greater than mod of minus 1 coefficient of y plus mod of coefficient of z. Next is mod of coefficient of y is greater than mod of coefficient of x mod of coefficient of z. And third one is mod of coefficient of z is greater than mod of coefficient of x plus mod of coefficient of y. So clearly it satisfies the diagonally dominance property, therefore the system is diagonally dominant. Now we will solve this system 1, 2 and 3 for x, y and z. We get x is equal to 1 by 4 into 3 plus y plus z. Y is equal to 1 by 6, 9 plus 2x minus z. And z is equal to 1 by 7 minus 6 plus x minus y. Now we will take initial approximation as, let initial approximations be x naught, y naught and z naught is equal to 0. Now we will put these values in this equation and we will get the first approximate values. First iteration x1, it is given by 1 by 4, 3 plus y naught plus z naught. As y naught and z naught are 0, so what we will get, 1 by 4, 3 plus 0, 3 by 4, that is 0.75. So x1 we are getting 0.75. y1 will be 1 by 6, 9 plus 2 x naught minus z naught. X naught and z naught are 0, so it will be 9 by 6, which is 1.5. Now z1 will be 1 by 7 minus 6 plus x naught minus y naught. X naught, y naught all are 0. So minus 6 by 7, that is minus 0.8571. So this is the first approximation. x1 is 0.75, y1 is 1.5, z1 is minus 8.71. Therefore x1 is 0.75, y1 is 1.5 and z1 is minus 0.8571. This is the first approximate values. Now second iteration will be x2 is equal to 1 by 4, 3 plus y1 plus z1. It is given by 1 by 4, 3 plus 1.5 minus 0.8571. And y2 will be 1 by 6, 9 plus 2x1 minus z1. That is 1 by 6, 9 plus 2 into x1, 2 into 0.75 minus z1, it is 0.8571. And z2 is 1 by 7 minus 6 plus x1 minus y1. 1 by 7 minus 6 plus x1 0.75 minus 1.5. If we calculate in calculator, we will get x2 as 0.9107, y2 as 1.8929 and z2 as minus 0.9643. So we have x2 0.9107, y2 1.8929 and z2 minus 0.9643. Now third iteration. So how we will get the third iteration? We will substitute this x2, y2 and z2. Therefore x3 will be equal to 1 by 4, 3 plus y2 plus z2. y3 1 by 6, 9 plus 2x2 minus z2. And z3 1 by 7 minus 6 plus x2 minus y2. If you calculate these values, we will get x3 as 0.9821, y3 as 1.9643 and z3 as minus 0.9974. Now fourth iteration. To get the fourth iteration, we will use this third iteration approximate values. x4 will be equal to 1 by 4, 3 plus y3 plus z3. y4 will be 1 by 6, 9 plus 2x3 minus z3. And z4 1 by 7 minus 6 plus x3 minus y3. If we calculate this in calculator, we will get x4 as 0.9917, y4 is equal to 1.9936 and z4 is minus 0.9974. Let us now find the fifth iteration using this fourth iteration approximate values. x5 will be equal to 1 by 4, 3 plus y4 plus z4. y5 is equal to 1 by 6, 9 plus 2x4 minus z4. z5 is equal to 1 by 7 minus 6 plus x4 minus y4. Now if we compute this fifth iteration, we are getting the approximate values x5 as 0.9991, y5 as 1.9968 and z5 as minus 1.003. We are getting x5 as 0.9991, y5 as 1.9968 and z5 as minus 1.0003. As we are not getting the same approximation, we will move to sixth iteration. Sixth iteration, x6 is equal to 1 by 4, 3 plus y5 plus z5, y6 is equal to 1 by 6, 9 plus 2x5 minus z5, z6 is equal to 1 by 7 minus 6 plus x5 minus y5. So we are getting 6 iterations approximate values as x6 is equal to 0.9991, y6 is equal to 1.9997 and z6 is equal to minus 0.9997. Let us now perform another iteration and see what approximate values we will be getting. Seventh iteration, x7 1 by 4, 3 plus y6 plus z6, y7 1 by 6, 9 plus 2x6 minus z6 and z7 equal to 1 by 7 minus 6 plus x6 minus y6. After performing 7 iteration, we see that x7 is equal to 1, y7 is equal to 1.9997 and z7 is equal to minus 1.0001. So look at this 6th iteration and 7th iteration. This is approximately 1. y6 and y7 are same and z6, this is approximately going towards minus 1. Therefore we will stop at 7th iteration and we can say that the approximate value for x is 1, the approximate value for y is 2 and the approximate value of z is minus 1. Therefore, the approximate solution of the given system by Jacobi method is given by x equal to 1, y equal to 2 and z equal to minus 1. So this is how we solve the system of linear equation using Jacobi iteration method. Thank you.